Hi, welcome back. This is Dr. Alex C. I would like to take this opportunity in this video recording to share with you about the washing machine integrated project. To begin, I'm now in this screen here, which is I'm in Mail. I'm using one of the Windows web browser, the Firefox. So I would first of all log into Mail, right? Navigate to your modules. For our case is the sensors and instrumentation module, so I'm going to click on here. That will take me to the Mail site for the module itself. I would then navigate further, okay, to see under the course documents. Okay, so actually what I'm trying to do is I'm trying to bring you to the lab sheet for this washing machine integrated project. So I'm here in the course documents. I will navigate down further. You should see a file, okay, called the integrated project washing machine. So you'll notice that there is a PDF lab sheet called the lab washing machine bracket final. So the objective of this mini project here is basically to let you experience the real world applications of washing machine as a standalone project, right? Which is very useful for students to learn about simple Q state machine or any state machine architecture programming. Now the learning objectives, as you can see over here, is highlighted, right? There are two main points really. To learn and understand the working operations of a standard washing machine. Now, a standard washing machine, which is a standard household item, will have several sequences that will need to be considered. Okay, so we will look at those. And also to learn and apply, in particular, this case is the QSM, which we have learned earlier in the traffic light state machine design. So basically it's a design pattern to implement this washing machine controller, and generally to kind of learn and apply what you have learned in using the LabVIEW DAQ, right, the data acquisition through the NI USB 609, right, where we learn about the digital I/O, which you are quite familiar now. We have done quite a fair bit of that in Lab 3 and Lab 4, and the digital logic control for this system. So without further ado, let me click on this integrated project lab sheet. Okay, so this is a mini project, integrated project for the washing machine. So okay, so let's begin. So I've already mentioned about the learning objective, right? So in this lab or this mini project, okay, we will be requesting that students get accustomed to the hardware in the lab. So later on, when you have the chance to get to the lab, okay, you will be able to see the actual system, right? So firstly, the device itself is the USB 609. Now the details of the washing machine part can be explored later. But generally speaking, the washing machine it comprises of a Intel 8051 microcontroller chip as well in the washing machine as the main controller. So in effect, what happens is that for us in the SIN module, we are only sending the I/O signals. I/O stands for digital I/O in particular, the digital input-output signals to this Intel 8051 microcontroller, which some of you may have learned in the other module called the MA, microcontroller and application module, right? So that MA Intel 8051 chip will then send commands to drive the actual power electronics and the motors drives circuits. Alright, so to begin, let's move on. So now, assuming that we are familiar, okay, we're going to plug in the USB, right? Which we don't have it at the moment, but allow me to illustrate further first. Now we will generally consider to build a front panel as shown, LabVIEW front panel. Your entry so-called the console on the front panel, you should have a start and also a stop button. And besides that, we should have also the washing machine display, like as you can see over here, right, to display the actual cycle of the washing machine. Now in this wash application, the washing machine only considers a couple of states of washing cycle. First is the wash cycle, you have the rinse cycle, then you have the dry. Now this pause one is optional. Okay, so generally there should be these three main washing cycle: wash, rinse and dry. These are just the indicators display anyway, right? So you could have a pause, you could have a stop. So but we will explore a bit more later, but the three main ones should be there, wash, rinse and dry. Okay, so it allow me to proceed to explain a bit more. In fact, it will be better that if you are in a class environment, in the lab environment, where a demonstration can be shown to you by your instructor. But let's take a look here. Now, if you examine closely, right, when you're in the lab, now they only utilize a few of these I/O ports, okay, the digital I/O. So this is just a pictorial view, you can see over here. Now the 6009, this is the NI USB 6009, as you can see. So the output interface basically to the microcontroller board is through these few interface pins, the interconnect pins, as you can see. So we are using the digital I/O control lines involve port 0, as you can see, port 0. Alright, so port 0 is the output port, and you have, for example, just to get some understanding of the notation, for example, over here you have port 0 line 0, right? Then you have port 0 line 1, port 0 line 2, port 0 line 3, right? These are the four output control ports or lines that we will set. Then okay, so just get yourself accustomed to first. So port 0.1 means is port 0 line 1. Okay, now also in addition we also have the input, so which is the port 1, which is the input port, which is shown over here, right? So the port 1 is the input port, and of course you can have a notation like port 1.0 means that port input port 1 line 0 input. Okay, so I think to better understand how this thing works is to really to look at this table, this table 1, where we have three main columns. So you have the digital input, right? We have the speed output. Okay, so we can control the speed of the motor, the running motor, and also the mode. Okay, so as I said earlier, you can see that these are the different ports that are being allocated. Okay, so these control logics here, okay, will indicate, for example, right, if I want to stop the washing machine under the mode, the output, I would send a pin line 0, port 0 line 0, right? I would send a boolean 0 or a logic 0 to this particular port. At the same time, I also will be sending a logic false or a 0 to port 0 line 1. So the combination of 0 and 0 would imply that there is a stop for the controller. So the Intel 8051 microcontroller, once they detect a 0 and a 0 in these two lines, it will stop the motor. Alright, so then of course I could have the wash as well. So the wash cycle is denoted by two pins. So if you send a 0 and a 1, okay, to the respective port, these two ports, it will signify a wash cycle. Now likewise for a rinse cycle, I would send these pins 0, 1, for example, over here, this combination. So this is how you interpret this table. So in order to control the mode of the washing machine, I will control sending the control signals, the digital control signals, to port 0 line 1 and port 0 line 0. Okay, so these are the few combinations. So 1, 1 would indicate a dry for these output combinations. Now on the other hand, I also can manipulate or control the speed of the motor. So the speed of the motor is given in terms of percentage. So you could have 25, 40%, 60% or 80%. So it's also controlled by two pins, two lines, which is port 0 line 3 and port 0 line 2. So if you offer the combination of say 0, 0, you are running the motor at 25% speed. If you run, if you send a control logic of 1, 0, in this case is 40% speed. 0, 1, over here 0 and 1 will signify 60%, and 1, 1 is running at the maximum speed, which is at 80%. Alright, so this is the way how we can control the speed of the motor as well. And then finally, of course, we also have the digital input where we can sense the water level. So for this port 1 line 1, right, this is for the water level sensing, and port 1 line 0 is for the motor rotation sensing. Alright, so we can see that, let's say for example, if we monitor the pin port 1 line 1, right, if it's when it sends a logic 1, it indicates that there's water in the washing machine. Water level is high, right, and 0 will be otherwise when it's water level 0. Okay, so I think it's quite clear now. If we understand the digital input and the various outputs, then we can proceed to consider how to control the washing machine operations. Right, now of course, when we first started the assuming that you're able to connect the USB 6009 to your machine, your laptop machine, then we can use the NI Max test panel to control and do some preliminary testing. So this is just a screenshot to show you, let's say if you connect the USB 6009, okay, which is attached to the washing machine board, then we can do some kind of a test. Okay, there are a couple of simple steps here which indicate step 1. Okay, you detect your device. For example, in this case, in this screenshot here is a device 6, but it depends on your machine. So you can select the device, then I can have a step 2, right, do a test panel. Okay, then you can do a self-test. Usually we do a self-test, right, to ensure that the connection is passed. Then we can proceed to step 3, okay, where we will launch the test panel. We will launch the test panel, then we can proceed to step 3. So assuming that the test panel is being launched, then we can select the digital I/O over here, where we can configure the I/Os, digital ports. So we will select, for example, step number 4, we will select port 0 as the output port, right? Okay, then you click on all output, then we can use step 6, right, where we choose the digital output, right? So earlier we mentioned that we can use the port 0, line 1, line 2 and line 3, right? So these two pins will control the mode of the washing machine, whereas the other two pins are pin 2 and pin 3, or line 2 and line 3 will control the speed of the motor, right? So you can use this to send some logic signals, right, to control the different cycles of the washing machine as well as the speed. And then you can click the start button here to update the this Max program, so that you will see some action running on the washing machine. Okay, so I'll leave you to practice, take a look at this later on. Okay, now the washing machine, simple washing machine operating rules are as follows. Just to illustrate, the washing machine will commence operation when you click the start button in your program, in the LabVIEW program in particular. So the simple washing machine cycle as follows. If you click start, right, in your LabVIEW program, the system will go to wash, rinse and then dry. And upon which, after the dry sequence, the program will sort of wait for the next command, right? Maybe the next cycle, the next customer who wants to use the washing machine to wash, okay, so they'll wait for the next cycle. So this is the typical flow, the washing machine cycle. But in between, of course, the program will be interrupted in a sense that if you click on the start, it goes to the wash, right? Imagine you are in the wash mode. Okay, now the washing machine would have to detect a water level. There must be water to be filled into the washing machine before the wash cycle can commence. So do take note that during once your washing machine state machine, once it enters into the wash cycle, right, the washing machine has to detect the water level to be in the high state. Okay, so you will be looking at the other pin, the digital port 1 pin. Remember, just to show you again, yeah, you'll be monitoring this one closely. Your port 1 line 1, you will have to be detecting the water level in this particular pin, signal pin, if you like. Okay, so and at the same time, once you come to rinse also, now there are two actions taking place in the rinse cycle, because the water needs to be drained off, right? After you wash, there will be a kind of a residue or not so clean water from your first round of washing, right? So you will have the washing machine in the rinse mode would have to discharge the water, right? At this stage, your water level must detect low, and then in order to rinse means you have to rinse it with clean water. So after discharging the water, you have to refill it with clean water. So that's the meaning of the rinse cycle. Alright, so before the rinse operation can commence. And then finally, for the dry mode, your washing machine needs to drain off fully discharge all the water before it can do a spin, dry and spin. Okay, so this is a typical operation, but I think the more detailed explanation could be in the form of a flow chart, which I have explained in the next figure 2. Okay, the detailed flow chart is as follows. So if we can see that the flow chart as follows, now we can see that the flow of the washing machine is as follows. When you commence the start of a program, this diamond box here means it's a decision box. So if you can see that there's a start here with a question mark, so which implies that if the user did not click on the start button, right, it will flow in this sequence. It will be no, right? If the person do not click on the start button, then the button itself will indicate as a no outcome, which means that the program will loop back. You can see this wiring that loops back in this flow chart. Loops back to wait. So basically, it kind of waits for the user to click on the start operation. So once the start button has been detected, it will be a yes. Then the program will proceed to fill water. So at this juncture, your program in your state machine here would have to monitor the pin for the fill water, right, which is the port 1 line 1, right, that we saw earlier. So if the water does not, the user does not fill in, the machine itself does not fill in water, then the system will be looping back in the no state, as you can see over here. So it means that you'll be keep checking until this condition is fulfilled. The water is filled, then only you can proceed to the next wash cycle. Else, the system will just be waiting for the water to be filled. Okay, so let's assume that the water is being filled. Okay, the user fills in some water in the system, right? So now this fill water sensor, the pin is light up. Okay, the fill water input signal is there. So the system will proceed to the wash cycle. Now in the yes mode, after you go into this dotted box here, will imply you are in the washing cycle. So the washing machine will turn on and continue running. Motor cycle will turn on. Now we will offer to delay the cycle. Otherwise, usually the wash cycle will be in terms of like a couple of minutes. Maybe you wash for about 20 minutes or 30 minutes. So, but to speed up the so-called description of this program to be more realistic, because otherwise we'll be waiting for a long time, right? So we would just delay for a short period of time. Let's say 12 seconds to 15 seconds is up to the programmer. So you will delay for a while. Then after that, upon finish washing, right, you'll come to this another condition again. So where we will detect again the water level, because we are going to proceed to the rinse cycle, right? Yeah, we're going to proceed to the rinse cycle. So first of all, we have to make sure that the dirty water, okay, is drained off lah. Okay, so we have to check again the water level. Okay, if the water level does not go to drain, your program will be looping here. So if it's no, right, that means you'll be keep looping around this corner here, this loop. Yeah. So if the water is yes, okay, the water level detected a low, right, which drains, right, then after that we can fill in the clean water, right, because I mentioned that the rinse cycle needs to drain water then to fill in the clean water, right? Yeah, so again now you have to monitor again the port 1 line 1, the water level pin. That one is very critical. So you will monitor the pin. If it's a no water is being filled, this program will be looping here and you'll be kind of waiting for the next activity to take place, which is the fill water. So assuming that the water level pin detects a high signal, then the washing machine will then proceed to the rinse cycle. So in the rinse cycle, you can switch on the motor again. In this dotted box here, right, is the rinse operation, whereby we will delay the cycle. Okay, let's give it some time to rinse, to do the rinsing part. Okay, so say put a 15-second delay in the rinse cycle. Then only we proceed to the last part. Remember that after the rinse operation is the dry cycle. So at this point in time, we introduce a condition here. We also monitor again the water levels pin. So now we will drain the water before proceeding to our so-called the final run, final dry run for the cycle. So at this point in time, we still monitor the pin. If it's no, the water level is low, okay, then we will proceed to the dry. If it's yes, if the water is still inside, the water did not drain, right, then you will be looping here, waiting for the signal pin to indicate drain. So if the water is really a rinse dry already, right, the water level is low, then you will proceed to the final run, which is the this dotted box here again is the dry cycle. So then we will continue to engage, turn on the motor. Okay, then we do the final dry cycle. Now what is also not mentioned here is actually after the dry cycle, the program could introduce a buzzer. Okay, so maybe you can add something around here to introduce a buzzer alert to tell the washing machine to have a beep sound. Okay, so let's say assuming you have that, then so the completion of the washing machine dry cycle then would take this program looping it back. Do you see this part here? So it actually takes the program loops back to the beginning again. Okay, when you can then go proceed or monitor the next start button where you can initiate the next wash cycle, the whole cycle again, right? So this is the full washing machine cycle description. Okay, as you can see over here, which I've mentioned over here. All right. Then of course there's some description here, right, to explain the washing machine. So I think it will be a good opportunity for students to explore and kind of build this washing machine cycle, because it involves quite a lot of thinking. Yeah, I think it's quite a good exercise for students to give it a goal or give it a try to how to develop this program, which will be very useful for all of us. Okay, thank you for watching and look forward for the next video. Thank you.